Good evening, students. Next, we'll continue with the remaining topics. So, next, we will check with the uncertainty in the KRR, that is knowledge soup in KRR. Uncertainty is whenever we are not have a proper information and the information is incomplete and imprecise and unreliable. That is, the information is not clear and the information is very less as it is required. Okay, then we can call it as the uncertainty in the information. So whenever we are dealing with the critical aspects or critical situations, then we require the each and every information is to be precise and complete information and reliable information. So while checking with this, so we can check the types of uncertainty in the KRR. So types of uncertainty in the KRR is, one is the incompleteness, that is whenever your information is not up to the mark and not complete information is provided, then we can say that that is information is incomplete information. Say for example, in the medical diagnosis, where if you are providing a symptoms of a patient as a incomplete symptoms, that is, say for example, actually I am suffering with the cold and cough, and you are informing to the doctor is only cold. So then the doctor is also gives the medicine related to the your specific symptoms. So that we need to give the complete information to the doctor, then only they can give the proper medicine to the patient. In a similar way, like imprecision, so whenever we are exactness of the information is lacking, that is exactly if you are not providing exact information, the correct information, then imprecision will be there. Example is high temperature. Say if you are saying a word as a high temperature, or rich is the some word. So high temperature is nothing but you are not saying exactly the temperature value. That is 95, 8 is also a temperature, 100 is also a temperature, 105 is also a temperature. So as in the same way, say if you are saying about a person as a rich, okay, how rich the person it is. Okay, if you are not saying exact value, then it leads to the confusion in the information. Next is the ambiguity of the information. If you are not saying the proper information or clear information or reliable information, it gets into the ambiguity. That is, if you are saying the same information in the multiple places, in the multiple times in a different way. Say some persons will be discussed like at one person they will be give the one information, and for other persons they will be give the information in the different way. So the ambiguity will be arised if the same information is shared in the people at different places in a different information. Okay, similarly like contradiction. So whenever you are giving a uncertain information, that is also the information is confused, or information is a dependent information. So then we will get the contradiction. That is, say for example, you are saying that some person has said some word or some sentence. So whenever you are saying that, if you are added some information or if you are removed some information based on the that is with the correct exact person conveyed information, so then this contradiction will get. Okay, say for example, all birds can fly, so while another says penguins are birds and cannot fly. Okay, so that is actually one person is saying that birds can fly, so and another person is saying that penguins are the birds but it cannot fly. So here we will get the contradiction, that whether the first person information is true or second person information is true. Okay, similarly like randomness. So whenever you are saying some information randomly between the different people, or whenever you are collecting the information from the different random places, so then also we'll get the contradiction, the uncertainty in the information. Next is approaches to handle the uncertainty in the KRR. So for handling of uncertainty, what are the different approaches we can follow? So one is the probabilistic reasoning. So using the probabilistic reasoning, we can check that whether the information is correct or not, and how much percentage it is correct, and how what is the probability of the information is being correct or wrong. Okay. So this is a one approach. Based on the reasoning, we can check whether the information is correct or wrong. And next one is the Bayesian networks. So in the probabilistic reasoning, we can use the methods. The one is the Bayesian networks. Based on the probability, we can check that whether the information is correct or not. So here we will check that based on the prior information, we will be check that the future information is true or false. So for that, we can use the Bayesian networks. And next is the Markov decision process, MDPs. This is also one of the method which is used to get this uncertainty approach. So here we'll have the decision making scenarios where actions are uncertain outcomes. Okay, so particularly useful for in a reinforcement learning, like where we will be get decisions based on the situation or based on the current condition, current state. So then we can use the our Markov decision process. Next is the fuzzy logic. Okay, where will be use the percentage of a probability, the degree of the truthness. So here also the value will be in between the 0 to 1. If it is less than the 0.5, it is a false. If it is greater than 0.5, it is a true. So if you are saying that somewhat hot, if you are saying the information as somewhat hot, so instead of strictly you are saying the hot or cold. So then you can be consider it as a whether you can have a threshold value. So if your information is less than the threshold value, you can say it as a cold. If it is greater than the threshold value, then you can say it as a hot. Similarly, we have next method is non-monotonic reasoning. So non-monotonic reasoning is generally for whenever you are getting into the conclusion based on some information. So the information is new or more precise information is available. Okay, then you can go for the non-monotonic reasoning. So this is very important whenever you are saying the reasoning. So based on the uncertainty. Okay, so that is the information is not exactly the clear and exactly not available. The information, precise information is not available. Then we can go for the non-monotonic reasoning. For example, if the new evidence suggests that the patient does not have a disease, that is, say for example, I have checked before the 10 days before, and based on that reports the disease is there, and the current report saying that the patient doesn't have a disease. So that is your that is, say for example, in the MRI, the person will be diagnosed for the some brain related disease, and after the some proper other test, if the person is not getting to that particular disease, then we can say that the precise information, based on the precise information, we can say that the current decision is changed. Okay. Next is the Damster-Shafer theory. So in this Damster-Shafer theory, so we can also call it as evidence-based theory. That is, whenever we are saying a information, if the information is non-evident, we can say that the information can be true or can be false. But whenever we have a proper evidence and exact evidence, then we can say that the information is exactly true. So here the example is with the basic probability assignments. So based on that basic probability assignments, we can say that information is exactly true. Okay. Next is the default reasoning. So based on the sum of default values, we can say that whether the information is correct or not. Okay, say generally, say for example, if I am saying that the student is studying a 5th class. So say if you want to have a age of a student, so general value of a 5th class student is something like 10 years or 11 years. So you can say that the general default value for a 5th class student age is the 11 years. Okay, like that we can say the some default values. Okay, and next is the augmentation theory. Augmentation theory deals with the reasoning based on the arguments. So based on the 2 or 3 persons or group of a people argument, based on that we can say that whether the information is true or false. Whether most of the people are arguing that the information is true, you can say it as true. Otherwise you can say it as a false. So here we'll have the counter arguments and conclusions and something like analyzing the strengths and others weakness of different arguments and selecting the most plausible conclusions. Okay. And next is the uncertainty in decision making. So whenever we are dealing with the uncertainty, there should not be any uncertainty within the decision making. So for that we can use the decision support systems. Using that we can take a proper decision without having the uncertainty in the data. Okay. So next we will go further than our next topic. So the continuation of the uncertainty. So expected utility based theory, that is based on some example or based on some application we can take our decision. Another one is Monte Carlo in the simulation. Based on this we can take a random sampling of a data, and based on that we can get the whether the information is true or false. So whenever we are checking with the data sets, so generally we will be check with the our random sampling. Based on this we can take a data, and based on the random data sets we can decide whether it is a right or wrong. Next is handling uncertainty in the knowledge representation. Okay, here we can be check with the probabilistic logic and Markov chains and epistemic logic. So here we can check the probabilistic logic is if it is greater than the 80%, then only we can say that it is true. Markov chains is we can represent our system is correct or wrong. Okay. So whenever we are taking a reasoning of information, then we can be check that whether it is a true or false based on the current state and future states. And another one is epistemic logic is it is a multi-agent based system. So it will be used in the multi-agent based systems. Okay, it just checks that whether how the agent will be work and how the agent will collect the knowledge from the different other sources and how it takes the decision. And applications of uncertainty in the KRR is whenever we are developing autonomous systems, then we cannot take any uncertain information. So we need to provide the exact information and reasoning based exact data. And next one is medical diagnosis. In this also we cannot provide any incorrect information or incomplete information. And for the robotic related also we need to provide the correct information based on the situations. And next one is financial forecasting. Also we cannot give the uncertain values. So sometimes in the financial forecasting we need to provide the uncertainties, that is we need to take our information is can be clear or can be changed with the conditions of the market.